Right. Physical quantities are basically classified into two types. Those are scalar physical quantities and vector physical quantities. So, this is our heading and here we have that same, because vector is also one of the physical quantity. I told anything which we can measure are said to be physical quantities. That physical quantities are basically classified into scalar physical quantity and vector physical quantity. But how can we understand which physical quantity is a scalar and which one is a vector? For example, so take temperature. We are taking a physical quantity, temperature. So, temperature is also one of the physical quantity because you can measure it. But when you go to the doctor, by using a thermometer, he measured your body temperature as say 40 degrees Celsius. So, what actually doctor is telling you? He is telling your body temperature a value. ఒక value చెప్తున్నారు. But now you have a doubt. Sir, you are telling me the value of my body temperature. If I ask you in which direction my body temperature is, నా బాడీలో ఉన్న టెంపరేచర్ ఏ డైరెక్షన్లో ఉందో చెప్తారా? If you ask like this, nobody can say. Nobody can say. Why? Because with the help of an instrument called thermometer, we can measure the value of the body temperature. But if anybody asks you in which direction your body temperature is, it is impossible to say. For example, can you tell like this, my body temperature is from top to bottom, or from bottom to top, from left to right, or from left to right to left? Can you tell like this? Impossible. So, with the help of an instrument thermometer, you can measure the body temperature value, but you cannot give any direction to the temperature. Such a type of physical quantities which have only value but no direction. So, the physical quantities which have only value but no direction, we cannot define any direction for such a type of physical quantities are called as a scalars. So, scalars are the physical quantities which have only value but you cannot give any particular direction. Examples of still scalars are distance. Distance is also one of the best example. For example, you are at say point A and you have to reach the point B. Okay, now you are choosing one path from point A to point B. Say this is that path. Now this path I can name it as a distance. Why? Because distance is a path which we cover in our journey from point A to point B without any particular direction. If you see this diagram, you can understand there is a gap between point A and point B, but I chosen one path without any particular direction. For this path, if anyone asks you what is the direction, in which direction you have traveled in this path, you cannot give any particular direction because it is irregular. So, for this path, say this is path 1, later we will get path 2 in our example. So, this is path 1, we call it as a distance. So, distance is the total path length which we covered from point A to point B without any particular direction, but there will be a value. So, what is the gap between A and B in which you travelled? You can say, sir, 5 kilometers. I have travelled a gap of 5 kilometers from point A to point B in this path without any particular direction. So, what you are giving for the distance? For the distance you are only giving the value, but you cannot give any particular direction. So, distance is a scalar physical quantity because distance has only value but you cannot give any direction. So, distance comes under scalar. One more thing, mass. Mass is also one of the example for a scalar physical quantity. What is meant by mass actually? The matter, padartham. The matter which is present in a body is called as a mass. If matter in the body is more, mass of the body is also more. So, the matter which is present in a body is called as a mass. Okay, I have mass in my body. If you ask me in return, sir, in which direction you have mass in your body? How can I say? I cannot say my mass in my body is from left to right, again from one finger to another finger. In this way I cannot explain, but I can give a particular value for my mass. Example, 80 kgs I am taking, 80 kgs. So if my mass is 80 kgs, I can give only for the, means I can give only value for the mass, but I cannot give any particular direction for the mass in my body, which means the matter present in my body. So mass is also one of the scalar physical quantity which has only value without any direction. Now when you come to the vector physical quantities, you can understand now. Vectors are also the physical quantities which have both value and also direction. Value and also direction. So vectors are the physical quantities which have both value and direction. Instead of the word value, in the higher classes we will use magnitude. The word magnitude also tells about value of the physical quantity. So vectors are the physical quantities which have both magnitude and also direction. Example, best example, displacement. Displacement is one of the best example for vector. Now come to the same diagram. For distance we have already discussed. Now there is, say, another path from point A to point B which is very straight, if you see. So say this is path number 2. Path number 1 is called as distance. It has value, but the path which you selected here, path 1, is does not have any direction. So we call it as a distance, and distance is a scalar. But path 2 is called as displacement. Path 2 is here called as a displacement. What is displacement? The shortest path between any two points. If you see the diagram, the first path is the longest path which is taking more time to reach point B from point A. But from the same point A to reach point B, you have another path which is the shortest. So that shortest path between any two points with a particular direction. If you observe this diagram, there is an arrow in this line. This arrow indicates in which particular direction your displacement is there. You are changing your position from point A to point B. So second path is called as displacement. Displacement have both direction and also value. For example, I am giving 2 kilometers. Compared to the path 1, if you see, it is where is the shortest one. So displacement value must be less than the distance in this example, in this diagram. Okay, it may not be same always, but in my example, distance value is greater than displacement. So here for the displacement, we are giving one value and you are moving in a particular direction from point A to point B, and you call this gap, which is the shortest one, as a displacement. So displacement has a value and also particular direction. So such type of physical quantities which have both value and direction are called as vector physical quantities. So the displacement is also one of the vector physical quantity. And example, second example, you can take force. Force, right? Here on the floor, I am keeping one box. And this is me. I am applying, say, 5 newtons of force. Example I am taking. So how much amount of force I am applying on this box? 5 newtons of force. You can even use the means direction, directly the directions also. For example, say this is east, west, north, south. Now tell me, in which direction we are applying force on that box. Even you can say directly, sir, that force is applied on the box by you from west to east. Are you watching? This is the direction of west and this is the direction of east. So in which direction we are applying force on this box? We are applying force on the box from west to east, means you are mentioning that the force which we are applying is in a particular direction. And also we intimated already how much amount of force we are applying on the box, that is equals to 5 Newton. So force is also one of the physical quantity which have value and also a particular direction. So force is also one of the vector physical quantity. In this way, many examples are there for scalars and vectors. So again, I am revising fastly. Physical quantities. Anything which we can measure is said to be a physical quantity, and physical quantity is basically classified into two types, scalars and vectors. Scalars are the physical quantities which have only value, but you cannot give any particular direction to them. Such a type of physical quantities are called as scalars. Examples for scalars are distance, mass, temperature, volume, electricity. So these are all examples of scalars. And come to the vectors. Vectors are the physical quantities which have both value and also direction. Examples of physical quantities vectors are displacement, force, weight of a body, like this. Many physical quantities comes under vectors. In the next class, we will go to the further concept. We will go to the next concept of continuation concept of vectors, which is types of vectors.